Welcome, my name is Evgeny Petelev, and I'm Senior Software Engineer in Technological R&D at MacPo. Today, I want to tell you about static analysis of macOS application bundle for territorial affiliation. A few words about me. I'm an enthusiastic software engineer who loves to solve problems. I have over 7 years of different technical experience, from iOS and macOS development to game development and reverse engineering applications. For the last 6 years, I have been a part of MacPo team, and I have involved in the creation of different products, such as Wallpaper Wizard, Xen Archiver, Clean My Mac X, and Spybuster. Now I'm doing technological R&D for our company. My work consists from different researches, and today I want to share with you one of them. You may be think, what is MacPo? MacPo is a Ukrainian company with headquarters in Kyiv. We develop apps that make your Mac life simpler. We do complex things in one click and solve 10 tasks with one tool. Because simple is the best. Our apps installed on every 5th Mac in the world. You may have heard about Clean My Mac, Setup, and Xen Archiver. Also, we have around 500 team members. So, let's back to our presentation. It consists from 4 parts. The first one is introduction. We will describe why it's so important to have a digital protection in modern world, and how static analysis of macOS application bundle for territorial affiliation can help us. The second one is static analysis method. We will consider what is it, how it works, and how we will use it. Then we will look at different static analysis approaches, explain how it works, and show some examples. During the last part, we will sum up all the information and share what is for us. So, let's begin. We will start from the introduction. Our goal is to research the possibilities of static analysis of macOS application bundle to determine the country of origin, developer name, and territorial affiliation. But why it's so important for us? Because some software is harmful and can result problems for your Mac. You may think that you could define whether an app is malware or no. I hope we'll succeed. This kind of apps really looks very strange. How to work with malware we know, because every Mac comes with antivirus software built-in system. macOS includes a technology called Xprotect, which scans your Mac for malware using database of virus signatures maintained by Apple. This is enabled by default, so you don't need anything to use it. If you download malware and try to run it, Xprotect can detect and stop it from running. Important to understand that Apple is not a dedicated security company, so Xprotect doesn't detect as many viruses as dedicated security. It's a passive solution. You can't run a scan to check your Mac for malware. But you can install apps like Clean My Mac, which may scan your device and find potential threats. So, we know how to protect your Mac from malware. But what about applications which we use every day? Are they safe? Can they make some problems for your Mac? Not all of the apps are safe, because some apps has a territorial affiliation, so they may have some problems with user data privacy. For example, in July 2016, Russia adopted the Yarvaya law that requires telecom providers to store private user data on Russian servers, including the content of voice calls, images, and text messages for 6 months. It also orders to retain metadata like sender and receipt information, send time, and location for 3 years. Online services such as messengers, emails, and social networks that use encrypted data are required to permit the Federal Security Service to access and read their encrypted communications. It means that all internet and telecom companies that have some presence in Russia are obliged to disclose the communications and metadata and all other necessary information to authorities on request without a court order. With all the input data from the above, we need a way to discover potentially unwanted software with connections to the territorial affiliation for further decision-making regarding its removal. Important that 58% of all world cyber attacks come from Russia. We will use static analysis to examine the macOS application bundle. It's very important to have a digital protection in modern world. So, what is static analysis? Static analysis is a method of computer programming debugging that is done by examining the code at supplementary resources without executing the program. The process provides an understanding of code structure and can help ensure that the code adheres to industry standards. Static analysis is used in software engineering by software development and quality assurance teams. Automated tools can assist programmers and developers in carrying out static analysis. The software will scan all code in a project to check for vulnerabilities while validating the code. So, we will explore different approaches to investigate macOS application bundle for territorial affiliations. We will talk about static database as deny list, bundle identifier analysis, App Store metadata analysis, code signing, information property list, bundle localization, macOS examination, and natural language processing. They will appear in order of priority. So, the first one is to use static database as deny list. A bundle identifier uniquely identifies an application in Apple's ecosystem. This means that no two applications can have the same bundle ID. To avoid conflicts, Apple encourages developers to use reverse domain name notation for choosing an application's bundle ID. The very basic and most common way of getting an affiliated application with the country is to have a static deny list. Applications can be identified by bundle IDs. On this page, you can see that we use the com.vk bundle ID substring to detect VK applications family, also called Vkontakte. As the other Russian applications, VK is required to permit the Federal Security Service to access and read users' encrypted communications. The next one is bundle ID analysis. The bundle ID itself could contain specific information for country detection. As mentioned above, reverse domain notation is widely used with bundle ID, so country ISO identifiers could be a part of it. On this page, you can see that bundle ID contains raw country ISO identifier. As the other Russian applications, Odnoklassniki is required to permit the Federal Security Service to access and read users' encrypted communications. Another approach is App Store metadata analysis. If the application is being distributed on the App Store, we can obtain its metadata by using App Store Search API. The Search API allows you to place search fields on your website to search for the content within the iTunes Store, App Store, iBook Store, and Mac App Store. You can search for a variety of content, including apps, iBooks, movies, podcasts, music, audiobooks, and TV shows. You can also call an ID-based lookup request to create mapping between your content library and the digital catalog. Important that the developers may use promotional content in the API, including preview of songs, music video, and app icons, only to promote store content, and not for entertainment purposes. On this page, you can see a response from App Store Search API for bundle ID com.vk.dom.vk-client. It has many fields that we will use in future. For example, seller name and artist name should be checked for well-known country-affiliated developers or developer sites written here. The next one is seller URL that should be checked for affiliated country domain extension. For example, if the country of interest is Russia, RU extension should be checked. Another important part of seller URL investigation is geo-IP information. Each domain corresponds to a particular IP address, which points to some physical server. To get the country of the server placement, we will use geo-IP services. macOS has built-in services called Whois. So, let's investigate geo-IP information. A DNS query can be used to obtain an IP address from the domain. Firstly, let's find IP address of domain using dig command. It's a tool for querying DNS name servers for information about host addresses, mail exchanges, name servers, and related information. This tool can be used from a Linux or macOS operating system. The most typical use of dig is to simply query a single host. Then, let's find more information about specific IP address using Whois command. Whois is TCP-based query and response protocol that is commonly used to provide information service to Internet users. It returns information about the registered domain names, IP addresses block, name servers, and much wide range of information services. Then we can analyze result and detect if physical server is located in a specific country. You can see how to use it on images below. But what about a code? Also, same functionality is available from getNameInfo POSIX function and Core Foundation cfhost start info resolution. On this slide, you can see a simple DNS resolver class that can help us to find address for specific domain. Next approach is code signing. Code signing is the process of digitally signing executables and scripts to confirm the software author and guarantee that the code was not being altered or corrupted since it was signed. Once the app is signed, the system can detect any change to the app, whether the change is introduced accidentally or by malicious code. You participate in code signing as developer when you obtain a signing identity and deploy your signature to apps that you ship. A certificate authority watches for our sign-in identity. Bundle code sign-in contains a variety of security information, along with the services that we use with the signature. Code sign-in information is available by security framework. So, let's investigate security framework. A security ref object for a certificate that is stored in keychain can be safely cast to a sec keychain item ref for manipulation as a keychain item. On the other hand, if the sec certificate ref is not stored in keychain, casting the object to a sec keychain item ref and passing it to keychain services functions returns errors. On this page, you can see how to use it. But one more thing. Unfortunately, certificate information is not available publicly, but you can use private API for these purposes. So, let's dive into the next approach. We will analyze information property list. Bundles, which represents executables of different kinds, contains an information property list file. This collection of key value pairs specifies how the system should interpret the associated bundle. Some key value pairs characterize the bundle itself, while others configure the app, framework, or other entity that the bundle represents. Interesting that the same keys are required while others are specific to a particular feature of the executable. The point of interest here are two keys: SUFIT URL and NS human readable copyright. So the first one is SUFIT URL key that came from third-party open source Sparkle framework. You may think, what is Sparkle? It's open source, secure, and reliable software update framework for macOS. So SUFIT URL represents the URL where the appcast feed is hosted. The same approach that was described in upstream metadata analysis could be applied here. The second one is an human readable copyright key that contains the copyright text which is shown on the About window. It often represents the developer website or company name. Also, we can apply the same approach that was described in upstream metadata analysis. Next approach is bundle localization. Localization is common practice of making the application accessible across the world. macOS applications can be localized by including string representation of translations that are applied according to the device location. So, what about some code? AppKit has native API that retrieves the bundle localization list. On this page, you can see how to use it. All you need is to check bundle localization property, and that's all. Next approach is MatchAllKit examination. Let's dive into it. MatchAllKit is the native executable format for binaries in OS X and is the preferred format for shipping code. An executable format defines the order in which the code and data in a binary file and read into memory. The ordering of code and data has implications for memory usage and paging activity, and thus directly affects the performance of your program. A match or binary is organized into segments. Each segment contains one or more sections. Core or data of different types go into each section. And segments always start on page boundary. By selection, are not thoroughly page aligned. But how we can use it for our purposes? CString section contains literal string constants, and it also quotes strings in source code. So they are definitely subject for our investigation for stored URLs in the binary. macOS has built-in tools named strings to parse binary files and search for URLs. So, how to find HTTP string constants in the binary? We will use strings command for these purposes. This tool looks for ASCII strings in a binary file or standard input. It's useful for identifying random object files and many other things. On this page, you can see how to use it. We combine strings command with grep to filter strings. Once we get a list of links, we can apply the same approach that was described in App Store metadata analysis. It's great, but can we perform this operation from code? Yes, all we need is to use MatchAllKit open source library. MatchAllKit is an Objective-C framework for passing match-all binaries used by Darwin platforms, macOS, iOS, tvOS, and watchOS. It's extremely useful. On this page, you can see how to parse URLs in binary. This part of code is used to perform search for strings in binary file that contains some string like .ru, vk.com, and yandex.com. Another part of bundle analysis is to detect the application's App Store title and description language with natural language processor. On macOS and iOS, this was available by Natural Language Framework. The natural language framework provides a variety of NLP functionality with support for many different languages and scripts. Use this framework to segment natural language into paragraphs, sentences, or words, and take information about these segments, such as part of speech, lexical class, lemma, script, and language. Nice, but what about a code? Language definition is available by an L language recognizer. Instance of this class automatically detects the language of piece of text. On this page, you can see how to use it. All we need is to pass input text as parameter. And that's all. An S language recognizer creates magic for you and get dominant language. Resolution. So, we explore different approaches to determine macOS application bundle for territorial affiliation. Static analysis of macOS application bundles simply yet powerful approach of getting country affiliation of the software. This will extensible mechanism that could be improved and reconsidered from time to time and even could be a basis for security-related software like SpyBuster or CleanMyMac. Why is territorial affiliation so important? 58% of all world cyber attacks come from Russia. Russian network intrusions effort in 42 countries. 63% of this observed activity has involved NATO members. The United States has been Russia's #1 target. Russian targeting has been successful 29% of the time. A quarter of the successful intrusions have confirmed the exfiltration of an organization's data. Why it's so important for us? MacPo creates SpyBuster during the full-scale invasion of Ukraine by Russia. SpyBuster is entirely free, on-device, anti-spyware app that helps users secure their data by weeding out apps with known connections with Russia or Belarus. SpyBuster is an up-to-date preventive application for users from all over the world. Also, the static analysis functionality of SpyBuster also got added for CleanMyMac X as a part of an installer module. SpyBuster uses approaches I described today. Whatever your way to choose the secure data, I hope you succeed. Thank you so much for your attention. Good luck.